Hello, this is Akarsh Sabbavarapu and my presentation is on research paper named What Goes Around Comes Around. The contents of my presentation are motivation of the paper, basic concepts, the importance of it, the problem, the approach it is using, what is the validation metric it is using, and the contribution of it. The, mo- the motivation of this paper is to provide a summary of 35 years of data model proposals by grouping them into eras. Author here is trying to show that there's a surprising regularity in each proposal. Some basic concepts in the paper are the eras of data models, which are hierarchical era in 60s, network era in 70s, relational era in 70s, and early 80s, ER era in 70s, then relational era, semantic era, object-oriented era, object-relational era, semi-structured era. Hierarchical era is with record types. They have limited flexibility. It has very few data storage options. Codasol era has record types and sets of connected graphs. This has record a time data manipulation language. ER data model was presented as an alternative to Codasol and hierarchical data models. ER model has unique keys and relationships between them. The, the relational era is proposed to encounter problems faced in maintaining applications. It has better logical independence with simple structure. R++ era is like an addition to relational model. R++ introduced various concepts like set attributes, aggregation, etc. SVMs are primarily focused on classes and groups of records on same schema. SVM is difficult for companies to implement. Object-oriented era is a genuine effort to have DBMS connectivity in programming languages, but it failed in making some core abilities. Object Object relational era was developed because of the need to have diverse data types and access methods in various markets. Semi-structured data introduced schema and query which allowed data instances to be specified beforehand. The importance of the paper is that it focuses on summarizing years of data model proposals to give an idea to everyone while highlighting the positives and negatives of each model. This paper gives the right ideas to future researchers on how to pick and adapt right models. The problem addressed is that there's a strong similarity and regularity in data model proposals from the beginning. The author argues that there aren't any changes at the core level. There's not much of a practical problem. The author's point is that no one should avoid The other point is that everyone should avoid repeating history. No one should make mistakes in data models. The approach is taken to give concise information. It is to enlighten the future researchers and help them making the same mistakes. Author provides lessons for each era. Lessons in IMS era. Lesson 1 says how data independence is not important. Lesson 2 says that tree-structured models offer less flexibility. Lesson 3 says that the restructuring the tree poses significant challenges. Lesson 4 says record at a time interfaces place burden on programmers. Lessons in Codacil era. Lesson 5 here says that the networks provide greater flexibility compared to hierarchies. And lesson 6 says that the loading and recovering networks are complex processes. Relational error lessons. Lesson 7 says that set type languages offer great advantages. Lesson 8 says that logical independence is more easy with simple data models. Lesson 9 says that technical debates are resolved by market forces. Lesson 10 says that query optimizers outperform almost majority of programmers. ER error, ER error lessons. Lesson 11 says that the functional dependencies are hard to grasp for non-experts, and so it reinforces the KESS principle. R++ error lessons. Lesson 12 says that with the absence of advantages, new constructs must be disregarded. Object-oriented error lessons. Lesson 13 says that the packages are not adapted until unless they offer great benefits to users. The OR error lessons. Lesson 14 is that the major benefits of OR are putting code in database and user-defined access methods. Lesson 15 says that the adoption of new technology requires high standards. Semi-structured data error lessons. Lesson 16 says that the schema is a niche market that may not appeal to most users. Lesson 17 says that XQuery shares a very close resemblance to SQL validation. There's no specific validation approach here. The author basically took various data models from each era and showcased how they handle and manipulate with positives and negatives of each model. Contributions. This paper has a scope to help future researchers by providing them with listing on data models. As this is the summary of how years and years of data model proposals has performed. Thank you.